Here we have an example dealing with polygons, and in this case it's going to be a rectangle story problem, which I know for some of you it can be kind of scary, but hopefully as I go through this I can take some of the scariness out of it and show you that if you break it down into smaller pieces it won't be quite as bad. So I'm just going to read through it first. It says the length of a rectangular garage is 6 times its width. Find the length and width of the garage if the perimeter of the garage is 280 feet. Now when you first look at it, it kind of sounds messy because it's long and it's wordy and so on. What I'm going to say is, let's look first in here, and it tells us that we're dealing with a rectangle. I'm a visual person, so I'm going to tell myself, let's draw a picture of the base of this rectangular garage. There it is. And now I'm going to start looking at the words. It tells me that the length of the garage is 6 times its width. So I think to myself, well, right now I don't know the length and I don't know the width. But it does tell me that the length is something in terms of the width. So what I'm going to do is I'm going to say that my width, since I don't know it, is W. In math, a lot of times if I don't know it, I'm going to give it a variable. So I know the width is W. Well then, if the length is, and is means equal a lot of time, 6 times the width, well, my length, which is up here, is 6 times the width. I'm going to take the width with this W and multiply it by 6. Now I have my length, I have my width. Well, in a rectangle, as we all know, opposite sides are going to be congruent. So now I have a rectangle that looks like that. My sides are all marked. I don't know the actual measurements, but I know them in terms of W. Now the next one, it says find the length and width of the garage if, now it tells me that the perimeter of the garage, this is supposed to be is, little typo here, is, so is, meaning equals 280 feet. So then what I do for my picture so that I have it, tells me that perimeter equals 280 feet. I'll leave my label off for now, but in the end I'll put it back on. Now what I want to do is I want to write an equation. Perimeter, I know, is the distance around. In other words, add up all the side lengths. Well, if I take all those side lengths and add them together, so there's the top one, call it the right one, the bottom one, and the left one, they're all my sides. That's the perimeter in terms of the W. But it also tells me that the perimeter equals 280 feet. Now I have an equation I can solve. Put all my like terms together, I'm going to end up with 14W equal to 280. Solve my equation, and I find out that W is equal to 20. Now I'm not done yet because, remember, the original problem asked us to find the length and the width. Well, really I've already found my width because W represented the width. So my width is going to equal 20, and then my label is feet because the perimeter was feet. All I have to do now is find my length. I'll go back to the words or to the picture, and it told me that the length was 6 times the width. I can plug 20 in for my width here and find out that my length is going to have to be 120 feet. Now you can do a little mental math here in your head. If these are really the widths and the lengths, well, I'm going to have 120, there's the top, plus the right. So now 120 plus 20 is 140. Add on the bottom. So now I'd be at 260, and then add another 20, and I'd be at 280 feet, which is my total perimeter, and I've solved the problem. And again, if we break it down into smaller pieces, it's not going to be quite as bad as if you try to do the whole thing all at once. And there's one example dealing with a little bit of perimeter and polygons.